Okay, hello, welcome to my channel. My name is Anch, and in this video we will find the derivative of the function y given as x raised to the power of x raised to the power of x, and so on and so forth. Right, so here is what we call infinite tetration of x, that is a repeated exponentiation. Okay, good. So just keep on building the powers, infinitely many of them. Anyway, this may be like a way too much for you to think about if you haven't gotten to know about this already. So let's think about a very simple case where we have y equals to x raised to the power of x, just the second tetration. So you're just raising x to itself. Good. Okay, so what happens if you're given this? How can you differentiate this right here? Well, the first thing I'd like to think about is bringing this power to the front, that is bringing it down, right? And we can do that using logarithm. So I'm just going to use the natural logarithm in this case. So I'll take the natural logarithm of both sides. So the idea is that we're given that y is x raised to the power of x, and we want to find y prime. That is, we just assume that this is y, okay? But this is the original, this is the main question we want to look at. Okay, so if that is the case, anyway, if you've known this already, just skip to the part where we begin the question, right? Good. And I hope this is going to be fun, and if you like the video, please forget to subscribe to my channel, right? Okay, thanks for subscribing anyway. Okay, let's continue. So after getting this, so this is going to be the natural logarithm of y equals to, so our aim was to bring this to the front, and that means we're going to have x times the natural logarithm of x. That is logarithmic property. Okay, so after that, well, the next thing would be to differentiate both sides with respect to x. So we differentiate the left hand side with respect to x, okay, and I will differentiate the right hand side with respect to x. Why not? Good. Okay, so the left hand side is natural logarithm of y, the right hand side is x times the natural logarithm of x. So differentiating the left hand side, this is the equality sign. This is a natural logarithm of y, so this is a function of a function because y itself is a function of x. Good. So since that is a function of a function, we're going to make use of the chain rule. So we differentiate the outside function. When you differentiate natural logarithm of y, that gives us 1 over y. That is differentiating natural logarithm of something, okay, to give us 1 over that thing. Then we multiply by the derivative of the inside, which means we're going to multiply this by the derivative of y. So let me use this notation anyway. Good. Okay, I don't like to mix notation, but just forgive that. Alright, so over here we'll also differentiate this, but notice this is the product of two different functions. This is x, which is an identity function. This is natural logarithm of x, which is the natural logarithmic function. So the derivative of the product, of course, how do we do that? Using the product rule. Keep the first function, differentiate the second. So when we differentiate natural logarithm of x again, that will be 1 over x, which I just explained over there. Then we add it with, that's the product rule, keep the second function and differentiate the first. So we keep natural logarithm of x, then differentiate x with respect to itself, which is just going to give us 1. So yeah, there's no point writing the 1, since that will just be a product. Good. So since the aim is to find y prime, which is what I wrote out here, to make that a subject, multiply both sides by y, which means multiplying the left hand side and the right hand side by y. So this is y, as the left hand side, and then the right hand side as well. So this y will cancel out with this y, then the second y will come over here. Okay, good. So when we multiply the right hand side by y, this is what we're going to have. So this is going to be, well, notice that x over x here is 1 plus natural logarithm of x. Okay, so that is y prime. But I want to write this right hand side as a function of x. So that means we're going to have y prime, that means we're going to have y prime equals to, this y here is x raised to the power of x. So I'll put the x raised to the power of x, and then that is into 1 plus that. Good. So let me just put everything together, into 1 plus the natural logarithm of x. So that right there is the derivative of y, given that y is just x raised to the power of x. This is what we get as a solution. Okay, good. So this should help you, or should make you appreciate this right here, where this is built infinitely. But anyway, even with this, you can also look at a case where the power is built up to 3 of them. That is the third tetration. You will use a similar strategy, okay, and then you will use the result from this second tetration into the third, and you can also continue to the fourth and so on. It's very, very interesting to try. So just give it a try on your own. And if you want me to do the video, please, you can put it in the comment section below. I'm going to do it anyway. Good. So let's look at this one. So we're given that y is x raised to the power of x and so on and so forth. So this is what I'm going to do to build up the power. So let me just change the color here. So that's x raised to the power of x raised to the power of x raised to the power of x and so on and so forth. Good. Okay, so this is what happens. Well, that's from what we're given. So we say but y from the given y here, okay, is said to be x raised to the power of x raised to the power of x and so on and so forth. So what do you see? Well, in that case, the blue y will become the blue x as a base raised to the power of, well, the green repeated exponentiation of the x, which is what we call y, because that's what is given. So that means that this right here is going to be y right here. So what do you see? Well, we can rewrite this right here as that y equals to x raised to the power of y, because from here is y again. Good. That's what I spelled out here by changing the color, and that is the y. So we just bring that substitution. So this right here is the same thing as that. So differentiating this would mean we differentiate that. Okay, so let's go over to a new page. Okay, so from what we established that y is the same thing as x raised to the power of y. So we want to differentiate this. We're going to use a similar strategy. We're going to take the natural logarithm to bring the power down and then continue from there. So I'm going to take the natural logarithm of the left hand side and then the natural logarithm of the right hand side. The aim is to bring this power to the front using logarithmic property. So this is natural logarithm of, sorry, let me use blue for that. So this is natural logarithm of y equals to y times the natural logarithm of x. Okay, that's nice. The next thing is, well, let me move all the y terms to one side. So I'm going to divide both sides by y, which means you're going to have 1 over y times the natural logarithm of y equals to the natural logarithm of x, because I've divided the y on the right hand side. Okay, so the next thing will be to apply, to differentiate both sides with respect to x. So I differentiate the left hand side with respect to x and also differentiate the right hand side with respect to x. So notice how how large the bracket is, alright? It covers everybody. Okay, so differentiating this, well, that will be by using the product rule, because this is a product of two different functions of y, and y itself is a function of x. So we are going to apply the product rule, and we're also going to apply the chain rule, because y is a function of x. Good. So we differentiate the first function. Maybe let me put it out step by step. So that means we're going to take the derivative with respect to x of the first function, that is of 1 over y. Okay, good. And then we multiply it by natural logarithm of x, and then after that we will add it with, we will now take the derivative with respect to x of the second function, which is natural logarithm of natural logarithm of y. Oh, sorry, this is supposed to be a natural logarithm of y, not like non-natural logarithm of x. So let me clean this right here. So this is natural logarithm of y, all right? Okay, all right, so over here, what was that? So this is going to be 1 over y out here. Okay, so notice that is just the left hand side again. Let me reiterate. We take the derivative of the left hand side, which is the derivative of the product. That will be by applying the product rule. So we equate this to what the derivative of this right hand side, which is the derivative with respect to x of the natural logarithm of x. Okay, that's nice. That's not nice. Alright, I think this should be better than before, so it's nicer. Anyway, okay, so this natural logarithm of y times the derivative of this. So when we differentiate 1 over y, okay, given that y is a function of x, and I'm using the chain rule again, that will become negative 1 over y squared, right? Then we have the natural logarithm of y multiplied by that. Good. Again, so we multiply this right here. Well, we differentiate this right here. The derivative of natural logarithm of y is a 1 over y. Then we multiply it by 1 over y. Good. Now observe that these two are functions of x, and like I said, we will use the chain rule. So this is where the chain rule come in. So I'm going to multiply everybody by the y dx, which means I differentiate the function of y multiplied by the derivative of y itself. Multiplied by the derivative of a function of y times the derivative of y itself. So factor out the derivative of y itself. Okay, then we will differentiate natural logarithm of x with respect to x, we get 1 over x. So in here we notice that this is 1 over y squared, this is negative 1 over y squared. So we can rewrite this as, this should be 1 minus 1, that is natural logarithm of y, okay, divided by y squared. That's because this has y squared as a denominator. This is negative natural logarithm of y, then this is 1 over here. So I've interchanged the terms and then I've taken note of that. Okay, so you take note of that as well. So this is dy dx, and then on the right hand side we have 1 over x. Okay, so maybe let's finish this off on the page. Alright, so let's see. Here we'll make the y dx the subject of formula. That means we're going to have the y dx. Well, let me just use the notation y prime. Okay, sorry for using different notations to represent one thing or one problem. So making the subject of formula means we're going to multiply both sides by y over 1 minus natural logarithm of x, sorry, y squared over 1 minus natural logarithm of x, natural logarithm of y. I keep on saying natural logarithm of x. Anyway, so that is y prime. But well, we can rewrite this using the fact that y from the given y is given as this. Okay, that is y is x raised to the power of x raised to the power of x, and so on. So you want the right hand side to be written in terms of x because we're differentiating y with respect to x. So that means we're going to have y prime to be, well, this is y squared. But since y is x raised to the power of x raised to the power of x, and so on and so forth, this is what we're going to do. So I'm going to write y squared as x raised to the power of x raised to the power of x, and so on and so forth. But that has been squared because this is y squared. Okay, so we square that, then we divide it by, this is x times 1 minus natural logarithm of y. But again, y is x raised to the power of x raised to the power of x, and so on and so forth. Good. Okay, so we have that right there. That is to close the natural logarithm, and then we have this right here to close this other product. Well, maybe you can expand the x inside, or maybe try to multiply this by itself and maybe play around with it. But this is a good place to stop, of course. For this where is a nice place to stop. Right? Good. So this right here is the derivative of the function given right here. Okay, I hope you enjoyed the video. Please, if you've not subscribed to my channel, do want to subscribe to my channel and stick around because I'm going to make interesting videos like this. And if you also want, or maybe have some questions or some problems you want us to try, please don't forget to put it in the comment section below. Okay, we'll see you in our next video.